Hey everybody, this is going to be an introduction to assignment 11, which would be our 3D rendering assignment. So hopefully at this point you've been able to install either V-Ray or Thea, or you've chosen to set up a remote desktop for the DAAP remote lab. You'll have to use one of these three options, and unfortunately none of them outside of the remote lab work on the Mac. So you won't be able to install V-Ray for Rhino for Mac, or Thea for Rhino for Mac. Those programs just don't exist. Unfortunately, there's just a lot less support for Rhino Mac than there is Rhino for PC. And even then, there's less support in the sort of rendering community for Rhino as compared to, say, 3ds Max, Cinema 4D, or some of the other programs out there that have even more options than Rhino does. Having said that, we still get quite a few good options for PC, and I'll be going over the ones that I've selected for this assignment and some of the others that are out there and why you might choose one or the other. So for this assignment, what I would like you guys to do is take either the precedent public restroom model that you had made in assignment 5 or the public restroom you had designed for Studio and bring that into the site that we have just constructed at the intersection of Elm and Liberty. So this is putting a project not where it began. So the public restroom moves, 4 blocks south. If you're using your own design, if you're using the design or the precedent, then someone else's, then it's just being relocated to this site. For my example, I'll be using the Barcelona Pavilion relocated to our site. What's important about this is we want to be able to see the context in your rendering. So in the example you see here, with a section perspective that's cutting through the building, we can see the buildings in the background with the line work that was done on top of them, so we can get an idea of how this building would fit into this context. And that is, of course, very important for renderings. It's not only good to understand your own building, but understand how your building relates back to context. You'll always have a context that you're dealing with. So for this, you can do either a interior or exterior perspective, or a section perspective. All of the above are fine. I would like these to all be at eye level though. So no cameras above eye level, so no bird's eye view, no worm's eye view. Try to keep everything at eye level as much as possible. And with these, the goal is not photorealism in general. I think photorealism is kind of a trap for architects and interior designers to do in school. There simply isn't the amount of time that you would need to really develop a full photorealistic image. In practice, it takes a long time before you could ever show a client a photorealistic image because there's so many decisions you have to make when you're dealing with photorealism. And they can look at every single aspect of the building, your material choices, trim, handles you've used on a door, all these things. And when you see them in photorealistic, you start to understand them as reality. Whereas a degree of abstraction allows you to not focus on these really minute details as part of an overall design and really more focus on the design itself. So the goal really is to focus more on defining space and sort of light as a sort of volume within that space and making renderings that really show light as best as we possibly can, because that's really one of the big benefits of using a rendering engine over just getting standard output from Rhino or any other program, is really the fact that you can not only get materials, which are nice, but get really nice quality lighting that is accurate. So from each, both Thea and V-Ray, we're going to export a series of images. There's slight variations between them, but they essentially will do the same thing. That will eventually compose in Photoshop. In Photoshop, I would like you to include at least 3 people in your image. My example that I have here, I just have some black and white figures, but any figures will work fine as long as they are scaled appropriately. In general, I'd like this to be 200 dpi at 11 by 17. So for this assignment, just when you're doing your renderings, with your final rendering, you want to set the output resolution to have a width of 3400. And the height will be whatever it is, depending on the aspect ratio of your screen, which I'll go over more in the individual demos. So there will be a separate demo for both V-Ray and for Thea. The process is quite similar for each. And in fact, we'll be exporting the same layers and really making the same materials in each and getting to the same sort of output. The difference is just, they're different softwares and they handle things slightly differently. The button locations are slightly different, and there's just minor little things that change with each one. So I have included multiple pages as part of this assignment sheet, with the first page including some basics that are going to be consistent for both programs, including some resources, which are some websites that have free available textures that you can use in your model. If you want to use these, you're welcome to. I would like you to use sort of a minimum of 3 different textures in your model, and this doesn't include glass, which I'd like you to use also, and water, which I'd like you to use also. And of course, I will show you how to make both of those. They're both quite easy to make, and of course, since we're designing a public pool, make a lot of sense to include. This will be due next Tuesday. This says Thursday. I will fix that on the assignment sheet. But next Tuesday, November 17th. So here we have first page, as I was mentioning, start off with those resources. One thing to keep note of here, and I have a big note about this, is rendering on your laptop is essentially the most intensive task that your computer will ever do. It is going to be using the most amount of power and creating the most amount of heat that it can possibly do. Now, this isn't necessarily a bad thing for your laptop. They're typically designed to do this from time to time, but it is a good idea to give it every advantage you can. So when rendering, don't ever render with your laptop on your bed. Any sort of insulating material underneath it will ensure that your computer overheats and could potentially cause damage. If nothing else, it will slow it down as your computer tries to rein itself in order to not overheat and damage itself. The next is propping it up on, I use little wooden blocks or something like that, can allow for better airflow underneath and around the computer. That's a great idea. Another very simple thing is if you have a desk fan, just placing it blowing at your computer when rendering can actually make a really big difference in keeping your computer cool. Especially computers that have aluminum shells like the MacBooks. That aluminum is a very good material for thermal transfer, so actually just blowing air across of it does a lot to help cool down your laptop. So once you have these installed, toolbars for each should just kind of appear in Rhino, but if they don't, you can right-click in the toolbar, as I've shown here, this little circle, and then go to Show Toolbars and go down and click on V-Ray or Thea, whichever one you've installed. These toolbars that you see down here, so I have both installed on my computer, and I've sort of pointed out what I think are the most important tools that we'll be using or that you might be using in the near future. So V-Ray, as you see here, has a significantly larger toolbar, and this kind of is indicative of V-Ray's, both more complexity that it has, but also more functionality in some cases. So what we have in the darker text color, the first thing is the asset editor. That is the most important thing in V-Ray. That is essentially where you do everything. Most of the other buttons in here can actually be accessed through the asset editor and essentially make the rest of the toolbar kind of useless. But the start render button, a lot of renderers tend to use the teapot as just a sort of standard for starting a render, and that's what they use in V-Ray. The frame buffer just pulls up the window that you rendered in. V-Ray gives you a variety of different sorts of artificial lights. For this assignment, I would like you to use either minimal or no artificial lights and just focus on the natural light in the scene. There may be circumstances where including natural or artificial light might be beneficial, but every artificial light you tend to add to a scene also tends to slow it down, as it's a new light source that has to be calculated. So in general, it's a good idea to minimize additional light sources outside of the sun unless they are necessary. V-Ray has an infinite plane, which is the next thing here, which is just essentially when it renders, there will be a ground plane that goes off into the distance. So it goes all the way to the horizon, which is kind of a nice feature to have. The next one I've highlighted is the V-Ray clipping plane, which essentially just allows you to create section cuts that will render. And that's all the ones I've sort of marked for V-Ray. In Thea, we have the start render button, dark room, which is going to be similar to the V-Ray Asset Editor, it's where you do a lot of the work in Thea. The content browser, which pre-created materials that you can sort of choose from, and display settings, which is going to be useful. So next, one thing that's consistent in both programs is the way you scale materials. For most all materials that you use in architectural rendering, the best way to do this is to do what's called box mapping. So once you've created a material, you can apply it, and creating materials is separate or done slightly differently for both V-Ray and for Thea, so I'll go over how to do them in each of the tutorials. But once you've created and applied it, you need to be able to scale it. And the way to do that is select whatever objects that you want it to scale, and then under Properties, navigate to this little tab here, which is essentially your material mapping, and go to Box Mapping. And just click this little box here. And essentially what it will do is ask you to draw out a box anywhere in your scene that essentially defines the beginning of the pattern of the texture that you're applying, and the end, and basically the scale. Once you've done that, you can adjust the scale. So it's in model units. So if you were in feet, this is 2 feet by 2 feet by 2 feet. And you can always come back here and adjust it. You can also re-click the box mapping at any time to reset the location or reset the scale in that method. And again, this is something I'll go over in more detail in the videos for each one. So I have several pages for each Thea and V-Ray. I'm not going to go through all of these right now because these are going to be covered more explicitly in each of the demos, but I just want to point out that these are here. And you can see at the top it says Thea notes. It will transition into V-Ray notes at some point. And it covers all, well, not every, a lot of V-Ray. V-Ray has quite a few more adjustments and settings that you can play with than Thea does. Again, it is a bit more of a complicated software. It can be a bit more powerful, but it has, more complexity to go with it. So again, I'm not going to go through all these. I will go through them in the individual demos, but just know that this is part of the PDF, and these are a good reference to go back to. One other thing I will mention is V-Ray does fairly frequently change the location of buttons. So I checked all of these menus and they seem to be the same location as the current version of V-Ray, but if for some reason you're running a different version than I am, or if something else is different, just know that they have changed several times, which can get a little confusing when they aren't consistent, when you get used to one configuration in V-Ray updates and they've moved things around on you. Anyways, so again, I've pulled up the website for several of these. Thea for Rhino is here. The advantages are, I think, quality-wise, they can produce as good of quality an image as both as V-Ray. It is free for students. You do have to sign up through the Altair University, which you just go to buy and go to student licenses, Altair University. And it should be fairly simple to follow the instructions and get that set up. It is free, as I said, which is a really nice benefit. There are several things that make Thea unique. It has multiple rendering engines built into it, which is sort of a confusing term, but it basically has a engine that's built for speed that we'll probably be primarily using, and then a couple other versions that are built for high accuracy when you really want to make sure that the way light is being moved and distributed around your scene is as accurate as it possibly can be. So next, go on to V-Ray. So this is V-Ray for SketchUp. I'll go to V-Ray for Rhino. So one of the nice things about V-Ray is there's a version for just about every program. It is really a popular software. It's widely used. It's extremely powerful. However, it isn't free. There is a free trial that lasts for 30 days, which will allow you to complete this assignment. But if you're planning to use this in the future, you would likely have to purchase a license, which I don't remember exactly how much it is, but something around $100 or a little over $100 per year to use it. It is fairly common within architecture and interior design for this to be the default renderer at firms. Not necessarily guaranteed, as it is one of the more expensive options, so not every firm opts to use it. Again, it has a lot of features, and there's certainly a lot of features that you'll probably never use, as it has so many things that are built into it for various purposes for people who have specific needs and desires, that many of which you'll probably never end up using. Again, it's very powerful. It's a really great option, but with all of the extra things they've added in, it also has more complexity to it. Now, next I was going to mention a few others. So this is not an option for you because this is the rendering engine that I use when I do my own professional work, but it is not available for Rhino. It is available for Cinema 4D, SketchUp, 3ds Max, Autodesk Revit, and Blender. So unfortunately, a variety of programs, but none of them happen to be Rhino. They do have an active forum, and I have advocated on that forum for them to make a Rhino version, but as of yet, they have not done so. What I really like about this one is the quality is really nice, but the amount of time I spend editing and getting the render set up in Indigo I find to be less before I get to an output that I think is a really good quality output. And some of that's familiarity with it, some of it's just inherent differences in the way the renderers work that allowed me to sort of get to that final stage very quickly. I care less about how long it takes for a single render to finish, because for the most part, even the highest quality render that I've done recently never takes more than maybe an hour or two. And in most cases, it's something where I could press render and walk away and maybe come back after having lunch or gone to sleep or something. So the actual render time matters a little bit less. And they're really not that different between the programs. It does depend greatly on your hardware. So all three, Thea, V-Ray, and Indigo, as mentioned, can run both on your CPU, which is your central processing unit, which is the primary processor in your computer, as well as your GPU, your graphics processing unit. And depending on your computer, you may have a faster GPU or a faster CPU, which allows you to complete tasks faster. So in my case, my GPU allows me to create faster renders using this, so I tend to go in that direction. In V-Ray, from my experience, the GPU rendering I found to be, let's say, a little less consistent in output and a little less consistent to get it set up properly. So it's not always something I recommend, especially on laptops that don't necessarily have a super high-end GPU. For Thea, I found both to work really well. I haven't used it much on a laptop, so I can't say for sure. But I'll go over more when we actually go through the demo for that. So another one I was going to mention is Maxwell, which is another rendering option that is available for, I think, a lot of different programs. So Cinema 4D, ArchiCAD, SketchUp, 3ds Max, Formzy, Rhinoceros, Cloud, and Studio, I think, are something separate. Again, a really good quality render, can use both CPU and GPU. The issues with it are primarily that it is not free. And there isn't a trial version that allows you to try it out without having, I believe, watermarks or limitations on it. So we can't do what we're doing with V-Ray necessarily, where rendering or just using the demo for this assignment, and you can decide later on, just because the output would be so limited. It is a really nice software. I've used it professionally before. It's very powerful. It's quite fast. It's very easy to use. But again, it's just not necessarily an option for us right now. Next one I was going to mention, Octane, which is a really powerful option. However, it has several requirements that make it not an option for this particular assignment again. So of course, as with all the others, it doesn't have a Mac version, as none of them do. But more specifically, it requires specific hardware or it will not run. In this case, it is requiring specifically NVIDIA-made GPUs, otherwise it will not run. And there's no way to guarantee whether or not your laptop has that or not. I mean, you could look it up, but I can't say for this assignment. It also does not have a free version, although they do allow you to rent monthly, so you could use this temporarily. It is a very powerful option, probably one of the best in my opinion. and can be done very fast, but again, doesn't work out so well for this. So I was going to bring this up because it's an interesting option, which is the cycles renderer, because this is actually the renderer that is built into Rhino right now. So if you have ever clicked the button where it says ray tracing and Rhino 6, it is using the cycles render engine. However, cycles render is an open source engine that is being developed with Blender, which is another 3D program, which is an open source free 3D program. That is incredibly powerful. That's used a lot in animation and the video game industry. However, the version of cycles that is brought into Rhino is comparatively, let's just say, very weak compared to the full version that is in Blender currently. However, Rhino 7 is currently in beta, and Rhino 7 gets a significantly more powerful, although still not full version of cycles in it. So potentially, if you are interested in trying out the Rhino 7 beta right now, which is available to anyone who has a license for Rhino 6, or if you end up upgrading to Rhino 7 when it comes out, the default rendering engine could end up becoming good enough for most purposes. And hopefully they continue developing it and incorporating all the features of cycles as it exists in Blender to really make it a robust option that could completely replace buying a third-party software, such as V-Ray or any of the others. So I still have hopes for the future for this. If you look up any of the sort of work that's done in cycles in Blender, it is incredibly powerful. It can make really beautiful renderings, both photorealistic and abstract. So again, hopefully a future in the or an option for the future. One last one I was going to mention is Corona. And this is another one made by Chaos Group, the owners of V-Ray. They actually a few years ago have acquired Corona. So this actually gets at the sort of primary difference between the three types of renderers in a sort of broad form that exists currently. V-Ray is a good example of what's called a biased renderer, whereas Corona, also made by Chaos Group, so the same company making two different renderers, is an unbiased renderer. Essentially, the difference boils down to this. V-Ray has a lot more settings that allow it to make approximations on the calculations on light that allow it to speed up the rendering process and skip over calculating, say, areas of the image that you're not going to see or not pay attention to as much. And essentially optimize the process to focus on the areas of the image that you really want to see. That's essentially what also adds the complexity to V-Ray, because a lot of the settings that you're going to be adjusting are essentially adjusting that bias as to where it happens, how it happens. So a good example of this is one of the essential controls within V-Ray, which is the quality of the output. A non-biased renderer doesn't typically have a quality control, because when you're using a non-biased renderer, it's just trying to calculate light as accurately as it can. So there's no such thing as sort of low quality versus high quality. It's always aiming for the best. Whereas V-Ray, you have a lot of different controls and toggles and things, and a lot of different optimizations that you can do that do allow it to work faster. However, there are just a lot more features and a lot more toggles to mess with to really understand what's happening and really be able to take advantage of that extra performance that the bias gets you without necessarily negatively impacting your image. So amongst the softwares that I've shown here, there's sort of a mix between the sort of bias and the unbiased. Another common characteristic of a unbiased renderer is that, as I said, there is usually not a quality toggle that you turn on or off. But oftentimes, when you start the render, it doesn't necessarily have a stopping point. Whereas V-Ray, you press render, it's going to render until it's done, and it's done. Maybe it takes 5 minutes, maybe it takes an hour, whatever it is, there's an endpoint. With non-biased renderers, not all of them, but a lot of them will just render as long as you let it render. And as it goes through that process, it's continually cleaning up the image over and over again. to the point of diminishing returns. If you left it for 5 minutes versus 10 minutes, you might see a difference. But if you left it for 2 hours versus 3 hours, you may not see a difference anymore, although it is technically more accurate. And then, of course, you could leave it for an entire week. But again, at that point, you might be going towards incredibly diminishing returns. Now, all of that's fine. You can set most of those rendering engines to stop at a certain sort of level of resolution or whatever, but it is a sort of characteristic of them that you're not necessarily defining the quality of the output image, but you might be just deciding how long do you want it to run for, and the longer, the better to a certain extent. And if you let it go really long, it might get maybe only a tiny bit better. There is another option beyond the sort of biased and unbiased, though. And it's best represented by software called Lumion, although there's a couple others, Twinmotion. These are the real-time rendering engines. And effectively, you can think of them as a video game. In many cases, that's literally what they are. Twinmotion is built on top of Unreal, which is a engine in which video games are built in. Both of these have some real advantages. They allow you to, you see this video on the screen in front of you. This is live. You could move around this as a video game and get an idea of what spaces look like. However, I am personally, and in my opinion, not a fan of these whatsoever. From my experience, they are sort of responsible for what I would call the simification of architecture in academia. And what I mean by that is, if you look at this image here, it's very pretty. But is it really about the building and the architecture, or is it about the things that are in it? And unfortunately, from my experience, these sort of real-time engines, because a lot of them, especially Lumion, come with a whole bunch of trees and furniture and all this kind of stuff, people end up spending more time on placing these objects in a scene and in a space than they do actually designing the space itself. And then there's so many pre-made things that I end up seeing the same couch over and over again, the same trees over and over again, and everything ends up just kind of looking the same. And another big difference is these are real time, so they're trying to update the image as frequently as possible. I mean, their goal is ultimately, typically, 30 frames a second. So updating this image 30 times a second, whereas the renderers we were just looking at were taking minutes or even hours to output a single frame. And the difference there is, again, similar to sort of unbiased versus bias. This is an extreme level of bias where the accuracy of the lighting simply cannot be nearly as accurate because they are spending so little time comparatively doing it. So in my opinion, again, the type of renderings you get out of it are less spatial because they're inherently less accurate to the way that light is being distributed. And the way light fills a space, to me, is really defines the spatial quality of that space. It's much less about the sort of random pieces of furniture and cool textures and lighting or whatever that's necessarily in the space. I don't even necessarily think that's necessarily interior design. I mean, it's architecture or interior design. I think it's the same. I mean, the volumes of space, the way we understand light moving through that space, I think is much more important than these sort of random things that you can add in. And again, these are both popular options. There's another one out there right now that I think it's Enscape. Does the same thing. And all three of these have become fairly popular within the industry, in large part because of how fast they are, because there isn't necessarily a commitment to rendering one image because you're rendering every image. It's a video game, so if you don't like the particular perspective you have, you can just walk around the building to a different angle and look at that perspective instead. So again, not my preference. I think across the board, when I've seen students use this, I have almost always felt their projects were worse off for it. So you can take my opinion with a grain of salt, but that's my experience so far. I do expect at some point, this type of software is only going to get better. And at some point, it probably will be a good option. But right now, to me, it makes architecture into sort of a video game, and not in necessarily a good way yet. So I prefer not to use these. I prefer, and also for this assignment, I would like you guys to not use these as an option. If you did really want to explore one of the other options out here, such as Maxwell or Octane, or well, that's probably the only options that really exist for Rhino, I would certainly allow it. That would be fine with me. However, the only demos I will be giving are going to be on Thea and on V-Ray. Okay, so again, I will give demos for both of these. I'm just mentioning this or showing you this. So I have my little Barcelona Pavilion model here that I've placed on the site. So this is exactly what you'll want to do. Not with your Barcelona Pavilion, but in this case with either your public restroom from the site way over here or the precedent restroom that you built in Rhino. Either options are fine with me. And then essentially we're going to create a single image from it. And just to give you kind of a preview, so I already have this guy set up to work fairly well with Thea. And I can turn it on. You can see here, I will show you how to make water that's fairly realistic. Again, because we're doing public pools, so that seems to make sense. And the sort of materials and lighting that are shown here, most of the stuff here is pretty basic. It's still using the sun system in Rhino. So if we start changing the time of day, you can see the shadows are going to update, and we can get a sort of realistic sense of what that space would be like at really any time of the day, any time of the year. So anyways, although I'm showing you right now this in Thea, it's essentially, these functions are nearly identical to the same things you can do in V-Ray. Okay. So if you haven't picked one or installed one, I would say choose either at this point. Again, I might have a slight bias towards Thea right now just because of the simplicity side of things. But V-Ray does have some more functionality that Thea doesn't. So, there's a balance there. I think for all the purposes that we have in this class and basically all the purposes you have in sort of undergrad architecture school, either one could be completely fine with you. Fine for you. And in fact, even beyond architecture school, there's not necessarily going to be a killer feature that V-Ray has that really means that you have to use it for its more power or whatever that Thea doesn't. But at the same time, V-Ray is more complicated, but once you learn it, it may not really end up being that much more complicated for you. It just has a bit of a steeper learning curve. Okay, so with that, look out for the videos, the demos for both V-Ray and Thea, and follow the one that you've decided to choose. All right, thanks.